Myself, Amadeshwaran. You have to dream before your dreams can come true. Quote said by Dr. APJ Abdul Kalam.
This is not the practical circuit. This is ideal circuit. Ideal circuit. No inductance without resistance. Because very thin wire is wound, very long wire is wound on a core. That's why it has considerable resistance. That's why it is not the practical case. So in that case, what you will get is the circuit will be like this. This is the practical circuit, RL. Because the inductance has resistance also. We put separately, that's all. But the coil has the resistance because of very long conductor wound on a core. That's why it has considerable resistance. That's why it has inductance as well as RL. And of course, the capacitor doesn't have any resistance, let us assume. So one of the practical circuits is like this. Suppose this capacitor is made up of what? What is the construction of a capacitor? Two conductors are of large area. Here, large length wound on a core, very long, very large, very long length, longest wire is wound on a core. That is inductance. The surface area is very large, means it is used in capacitor. So it is very large area. That area is separated by a dielectric medium. Here, a dielectric medium is between these two. Some dielectric medium is there. Insulator. This is separated by insulator. That is capacitor. That you know. You studied already. Where you studied? +2 only. Not here. Basic electrical engineering have studied. So two conducting surfaces are separated by dielectric medium. Dielectric means insulator. Dielectric medium means it is called capacitor. Here, this dielectric medium is ideal resistance. Ideal insulator, sorry. Ideal insulator we are thinking, but it is not so. It has some resistance. Then the practical circuit will be like this. RC, RL and capacitor, inductor. The circuit will be like this. First, let us find what is the resonant frequency for this first one. For that, what is Y equivalent? Y equivalent equal to 1 by R L plus J omega L. 1 by RL plus J omega L plus J omega C. J omega C. Where? No need. This R itself will give resonance. This R itself will give resonance. This R has considerable value. This RL has some considerable value because of very long conductor is wound on a core. That's why it has considerable resistance. So this for this Y equivalent equal to 1 by RL plus J omega L plus J omega C. If you multiply the numerator and denominator by complex conjugate, you will get RL minus J omega L. The denominator you will get RL square plus omega square L square plus J omega C. So it can be written as RL upon RL upon RL square plus omega square L square plus J omega C minus omega L divided by RL square RL square plus omega square L square. So this is equal to 0. At resonance, at omega equal to omega naught, at omega equal to omega naught, the complex part is equal to 0. Therefore, you will get omega C minus omega L divided by R L square plus omega square L square equal to 0. Find omega naught. Omega naught square L square C omega naught square LC plus RL square C equal to L, or you can write omega naught square equal to L by L square C minus RL square C divided by L C R L R suffix L R suffix L square C divided by LC. C getting cancelled. Here L getting cancelled. Therefore, omega naught equal to square root of 1 by LC minus R L square divided. Therefore, F naught equal to 1 by 2 pi square root of 1 by LC minus R L square divided by L square. Find, take down. Find the resonant frequency when RL equal to 5 ohm, L equal to 0.5 Henry, and C equal to 0.5 microhenry. Find the resonant frequency for the circuit, for which just now we have derived. F equal, find the resonant frequency for RL equal to 5 ohm, L equal to 0.5 Henry, C equal to 0.5 microfarad. To substitute in this, F naught, find the resonant frequency F naught equal to 1 by 2 pi square root of 1 by L equal to what? 0.5 in 10 power, sorry, 0.5 Henry, I said. Multiplied by 0.5 microfarad into 10 power minus 6 minus RL 5 square divided by L square 0.5 square. That's all. So what is resonant frequency? How much? 300 and hertz. 318.30 hertz.